Hello and a very warm welcome to the Valves community webinar Will Ammonia become the first truly green marine fuel? Here live from the Herose studio in Bad Oldesloe. My name is Mario Esche and I'm responsible for the marketing in the Herose group. And I will be the moderator for the next webinar here. Today with me I have our specialist Sebastian Grader.
Thank you, Mario. Hello to the audience from my side as well. My name is Sebastian Grader. I am responsible for the cryogenic portfolio within the Herose group. And yes, I'm happy to be here to talk about the ammonia topic and to be a part of it.
Yeah. Well, before we start stepping into the details of our webinar, I want to show you the agenda of the major topics which we are going to talk about. You can now see that we have divided our webinar into 4 topics. We will start with the development of the fuel mix in the shipping industry, and we will have an outlook of the next years. After that, I will give you a short overview about ammonia, a chemical compound of nitrogen and hydrogen. And then Sebastian will step into the materials selection when it comes to the use of ammonia. And at the end, we will round up with the product solutions which we have once you want to build up a ship running on ammonia or upgrade an existing ship. Let us start already with the first topic. And there I have the question, Sebastian, for you. How has the fuel mix for ships developed in the recent years and what are the major driving factors?
That's a good question, Mario. The main drivers for the alternative fuels in the marine sector is clearly the reduction of the CO2 emissions. There is a stepwise reduction of the CO2 emissions up to 2050.
Okay, and how will the future look like in detail?
LNG has dominated in recent years. Herose built up and served a large customer base for this, and alternative fuels is important to the whole industry. And in the future, we will see a decline of the fossil marine fuels and a mix of alternative fuels. And for this, let's have a look at a graph for the energy transition. This graph shows you the development of the fuel mix in the shipping up to 2050. The transition shows you in the x-axis shows the timeline from now to 2050, and in the y-axis the percentage distribution. The fuel mix is currently have a large share of fossil fuels like marine gas oil and heavy fuel oil, and a small percentage of alternative fuels. When we look now in the future, the fossil fuels will decline by 2050. The share of the alternative fuels are increasing, and the 2 main drivers at the bottom will be LNG and ammonia. By 2050, the DNV estimates that the share of ammonia in the energy mix for inland and ocean-going vessels could grow to 25%, alongside LNG, diesel, heavy fuel and biofuels.
Okay, so we see that there's the estimation that we will have LNG and ammonia in the future in 2050. And the question what I have is, will ammonia become the first truly green marine fuel then?
Yes, this is our topic question of this webinar, and ammonia has the potential to do this as soon as the green manufacturing process is economically scalable.
What does that mean, a green manufacturing process?
Green manufacturing process or production means that all energy comes from renewable sources like wind or solar, etc.
Okay, thank you for the insight of the fuel mix development into the future. I would like now to show you a little bit more about ammonia itself, and therefore I have prepared 2 slides and a small experiment, and I will start with the history of ammonia. Therefore I would like to draw your attention to the slide here. And there you can see that ammonia was already used in the end of the 19th century as a fuel in streetcars in New Orleans. Then ammonia was used in Belgium to drive buses with ammonia. And in 1981, a Chevrolet Impala was also running on ammonia. Today, we have the total production of ammonia of about 200 tons per year, which is mainly used for the fertilizer business. And there are also today activities to establish ammonia as a green fuel for the shipping industry. If we have a look at the equation of ammonia, you can see that there are two compounds. There's on the one hand nitrogen and on the other hand hydrogen. And within the Haber-Bosch process, which was developed in the early 20th century in 1909, there a catalyst is used running under 300 bar and 450 degrees Celsius to process ammonia. If we now have a look at the chemical characteristics of ammonia, you can see that ammonia, that is a purgent smelling gas under the room temperature. It will be liquefied at minus 33 degrees Celsius, which makes it very easy to handle ammonia, to transport it or to store it. The calorific value of ammonia is much lower than diesel, which is round about half of it. So if you decide to use ammonia as a fuel for shipping, then the storage tank will be much bigger on your ship. In connection with moisture, ammonia is highly corrosive to copper alloys. And therefore, now we have prepared an experiment just before the webinar starts. You can see here that we have three different scenarios. One scenario is that we have ammonia, a mixture of water with 25% ammonia. The second glass is showing ammonia, the mixture with water, together with copper alloys. And the third glass is showing ammonia with stainless steel. And you can already see that on the second glass, where we have the ammonia with copper alloys, that there's a reaction which results into a blue color. And that shows that there is already the corrosion process is started. Okay, having these now in mind and coming back from the experiment to the topic of the webinar, I want to draw your attention now to the third topic, that what influences has these on the materials. Well, I will start with the first question I have here. How did Hirose come into the topic with ammonia now?
That's a good point. Hirose came to ammonia through our customer relations. Hirose, we received multiple requests on this topic, so we build up and want to be able to offer a solution for our customers' solutions. Applications, sorry.
Okay, yeah. For these solutions, what impact does the use of ammonia have now on the selection of materials, Sebastian?
The ammonia reacts highly corrosive with copper and copper alloys, as we already have seen in the experiment. And for this, we split the ammonia in two types. The first is dry ammonia. Dry ammonia means that it is anhydrous. There is no reaction, as you can see there, for the stainless steel. And when it's dry, it also has no reaction to the copper alloy. The second type is the wet ammonia, and this is what our experiment shown. There is a corrosion with the copper alloy. So we know that globally 95% of the ammonia stock is considered wet, and we have adapted our portfolio to this, so we have a solution for our customers.
Okay. Having this fact in mind, how does it now influences on the material selection?
That's a good point. For this, I want to show you a slide and a sample. Here you can see a picture of our stainless steel valve. It is our series 10341 and a drawing section. Our standard portfolio has a bush which contains copper alloy. You can see this marked in red on the drawing here, and I would like to show you this too on our example here. So here you can see the valve. The outer parts are all of stainless steel, and when I took out the top works, here you can see at the spindle thread there is the bush. So to have a better view of it, this is the bush you see, the material is copper alloy. So when the media ammonia comes into the body, into the inlet, and the flow goes through the body, the bush comes in contact with ammonia, and so when you have wet ammonia, we have to change this part. When we change it into stainless steel, some of you will ask, what is with the cold welding process? Because our spindle is out of stainless steel and the bush as well. And for this, Hirose has an internal process, a hardening process, so the thread is hardened, and in order to avoid cold welding, the spindle is threatened by a hardening process, this ensuring the long service lifetime of the product.
Okay, so when we have a look at the material selection, we have to keep two things in mind. We have, on the one hand, we have the bush, which is with copper alloy, and on the other hand, we have the spindle, which needs to be hardened. If we now look on the other side, at the customer side, what does he need to consider if he wants to use ammonia as a fuel in his system?
For this, we have built up a solution. We have two scenarios, and I want to show you that. The first scenario, as you can see on the next slide, the first scenario is that the customer has an existing LNG fuel chip, and so the valves are out of the standard portfolio, and the customer wants to upgrade it to ammonia fueled, and we have spare part kits with the inner stainless steel parts, and the customer just have to change the top works and it is ammonia ready. The second scenario is that the customer wants to build a new ammonia fuel chip, and for this the valves are supplied in the ammonia version, and the chip is already ready to operate with ammonia fuel.
Okay, these were already the major parts which we have to consider on the material side, which we have to consider when building up an LNG or an ammonia fueled system. So I would like, before we come to an end of this webinar, I would to summarize a little bit the points what we have found out and discussed during the first minutes here in the webinar. We had a view on the development on the shipping industry and the fuel mix, and we saw that there will be a mix of LNG and ammonia in the future in 2050, and the question, will ammonia be a green fuel, can only be answered with a yes if the production of ammonia will be based on a green process. After that, I showed you the chemical characteristics and the behavior of ammonia when it reacts with copper alloys. Sebastian told us what materials have to be changed if we use ammonia, and at the end we showed you the product solutions which we have when you want to create an ammonia ready system or when you want to build up a new ship. Yeah. In preparation of this webinar, we already got some questions which we want to highlight over here and which we want to answer here directly in the webinar. And the first person who wrote us said he's designing currently an LNG fueling system, Sebastian, and he's now asking whether he needs to have already the materials selected for ammonia.
No, of course not. It is not necessary because our standard portfolio is suitable for LNG, and there has to be a retrofit when the ship has to be made ready for ammonia.
Okay, and there was another question coming up that the person who's currently handling an LNG ship maybe wants to use ammonia in the future, but he does not know whether the ammonia is dry or wet. What solution or what recommendation do you have for this? So
the Hirose recommendation is that the ammonia ready version is installed, because we know that 95% of the globally stored ammonia is wet. So to be sure that there is no corrosion, they have to choose the ammonia ready systems and valves.
Okay, and the last question what I have on my paper is there's one scenario that the company wants to upgrade his system to ammonia, and which activities have to be done?
It's very easy. The activities which have to be done is that our spare parts contain the ammonia ready topworks. So the standard topworks must be replaced and assembled, but the bodies don't have to cut out the piping system, and so it is not necessary to cut them out, and then we just have to retrofit it.
Okay, yeah, retrofit. Is there any service or assistance available from Hirose?
Yes, Hirose has a service team globally available, and if the customer needs it, just call our sales team, and yeah, we are proud to give the service team.
Thank you. Yeah, we are now at the end of the short webinar, and we thank you, and I thank Sebastian for his time here.
Thank you, Mario. Thank you to the audience for your attention, and see you next time.
Yeah, also a big thank you from my side for your attention and for taking part in the webinar. I would appreciate if you visit one of our next webinars in the future, and I wish you a good day, stay healthy, and goodbye.
Bye-bye.